Hello students, this is Zila Sleep Physics. I shall teach you today relation between electric current and drift velocity. Also derivation of Ohm's law. So we know metals have a large number of free electrons. So nearly 10 to the power 28 per meter cube. In the absence of any electric field, these electrons are in a state of continuous, random or haphazard motion due to thermal energy. Remember the word thermal energy. At room temperature, they move with the velocities of the order of 10 to the power 5 meter per second. So they are moving randomly or haphazardly in all sort of directions. They are colliding with the walls of the conductor and they are also colliding with each other as well as with the positive ion. These electrons are continuously in motion and these velocities are distributed randomly in all directions, 10 to the power 5 meter per second. There is no preferred direction of motion. On the average, the number of electrons traveling in any direction will be equal to number of electrons traveling in the opposite directions. So there is no net flow of charge in any direction. Now this is a conductor of length L, area of cross section A, and we have created an electric field. We have put an electric field by applying a potential difference V. So electric field is set up, E is equal to V by L. So under the influence of electric field E, the free electrons begin to drift in the opposite direction of E. So E has a direction like this. So from positive to negative, and the electrons being negatively charged, they starts drifting towards the positive terminal of the battery, just opposite of the of the direction of the electric field. They have to move because electric field creates a force, electrical force, and that accelerates the electrons towards the positive plate of the battery. So they start drifting with the velocity, drift velocity Vd. Now let the number of electrons per unit volume or electron density be small n. First of all, we take the total number of electrons as capital N and electron density or number of electrons per unit volume as small n. Now also charge of an electron as small e. Therefore, number of electrons in the entire length L of the conductor, that is capital N, is equal to small n into V, is equal to small n into A into L. Now let us take total charge as Q. So Q is equal to charge of an electron multiplied by capital N, that is the total number of electrons, is equal to E N A L. All the electrons which enter the conductor at the right end will pass through the conductor at the left end with a time t is equal to distance by velocity, that is L by Vd. L by Vd. Therefore, current I is equal to Q by T is equal to E N A L by L by Vd. So electric current is equal to E N A Vd. So this expression has come in ISC 2023. It's a very important expression. Numericals are set on this. Let's go through it. After this I will deduce Ohm's law. For that I have to rub the board. Okay, I am doing over here. Start doing over here, utilizing this space. So when a potential difference V is applied across a conductor of length L, so electric field E is equal to V by L is equal to V by L. And the expression for the jet velocity, we know that E relaxation time by M. We know what is relaxation time. It is the average time between two successive collisions of an electron. So let us put the value of E over here. So it becomes E so this is the expression. Now if the area of cross section of the conductor, we have already assumed is at A, and the number of electron per unit volume or the electron density is N, then I can write again like this E N A V D, the same expression I proved here, so I am putting it here. So now what I am doing, I put the value of Vd in this expression. So it becomes E N A into, in place of Vd I put E V tau by Lm. This tau, don't mistake it with L. So it becomes N E square A V tau L M. I'm rubbing this part, so I have to use this space. So now this I, so now V by I, see I is equal to N E square A V tau L M. So V by I is equal to ml A d square tau A. So if you see this expression, if you watch this expression carefully, you find that the quantities m, l, n, e, tau, and of course area of cross section have constant values for a given conductor. So so all these are constant. So we call it resistance R. So R is the resistance of the conductor. So I write R as ml in E square tau A. So this is the resistance of the conductor. So this proves the Ohm's law. So we have deduced the Ohm's law. Now another part I will do today, resistivity in terms of electron density and relaxation time. For that I have to rub it off. Please look at these expressions carefully. So we have got R, the resistance of a conductor, we call it. So after that I have to rub it off to do the next expression. So I'm rubbing out everything. So now we know this expression very well. R is equal to rho L by A. R is the resistance of a conductor, rho is the resistivity, L is the length of the conductor, and A is the area of cross section. And now, just before this, we have found R as ml in E square tau A. So compare these two. So we're comparing, we get rho as m n e square tau. So this is the resistivity of a conductor. Now if you look at it very carefully, you'll find that rho is independent of the dimensions of the conductor, but depends on two parameters. Number one, small n, that is the number of free electrons per unit volume, or simply electron density of the conductor, the number one. Number two, relaxation time tau, the average time interval between the two successive collisions of an electron. So this much for today. Thank you very much. Thank you all for watching this video. If you like it, if you have any problem, you can mail me at my mail address, and I will come up with another topic next time. So bye bye from here today. Thank you.